first things first, we're going to start by talking about what a chord is. A chord, very simply put, is a segment whose endpoints are on the circle. So if this is my circle, anybody who has endpoints on the circle is a chord. All right, anytime we have two angles, or angles that are formed by chords, it's going to be inside the circle, but unlike the central angle, not necessarily at the center of our circle. Now the measure of this angle that's formed when two chords intersect is equal to half of the sum of the measures of the intercepted arcs that are associated both with the angle and with its vertical angle counterpart. So that's a little bit confusing. Let's see if we can take that apart and make it make some sense. What this is saying is that if we want to find the measure of angle 1, notice that its vertex is inside the circle, but unlike the central angle, its vertex is not at the center. His measure is going to be formed by taking the sum of his intercepted arc. And if we look at the picture, his intercepted arc goes from A to B, and the intercepted arc of his vertical angle. So if we look across, there's his vertical angle, and the intercepted arc of the vertical angle is going to be the measure or the arc from C to D. So in other words, the measure of angle 1 is going to be equal to half of the sum of the measure of arc AB plus the measure of arc CD. The other pair of vertical angles in this picture, this angle over here and angle 2, they also have a pair of intercepted arcs. That arc goes with that angle. The blue arc over here goes along with angle 2. So the measure of angle 2, again, his vertex is inside the circle, but not at the center. So his degree measure is going to be half of the arc that belongs with him, so arc AD, and the arc that belongs with his vertical angle, which is arc BC. All right, that's the first important rule that you need to remember for today. Anybody whose vertex is inside the circle has a degree measure that's equal to half the sum of his arc and his vertical angle's arc. This video doesn't run for too long. This guy's a little bit different. I do want you to see an example of how we solve a problem where the vertex of the angle is inside the circle but not at its center. So this is a perfect example. Vertex is in the circle but not at the center. We know that the center is marked by that little black dot. So the measure of the angle is going to be equal to half the sum of its intercepted arcs. Well, the angle in this particular case is 53 degrees. There's its arc, the 3x plus 3. Its vertical angle is over here. The intercepted arc of the vertical angle is this 10x minus 14. So 53 degrees is going to be equal to half of the sum of those two arcs. So half of 3x plus 3, the red arc, plus 10x minus 14, the green arc. So in order to solve this, I'm going to begin by combining everything that's inside the parentheses. In order to get rid of this 1/2, I'm going to multiply both sides by 2. I'll add 11 to both sides. And lastly, to undo multiplying by 13, I'll divide both sides by 13. So I come up with a value of x equals 9.